good morning to our lecturer Puan Mahani and my fellow friends. In this presentation, I and my friends are going to present about heat exchanger. Before that, I wanna introduce myself first. My name is Udayan, son of Sundararajan, and my matrix card number is 01DPU19F1017. Let's get into the slides. Okay, firstly, what is a heat exchanger? The diagram shows what is a heat exchanger. Heat exchanger is a device to transfer heat or thermal energy. A fluid can be either liquid, vapor, or gas. Depending on the type of heat exchangers employed, the heat transferring process can be varied. Heat exchangers either given a hot fluid to provide heating or a cold fluid to provide cooling. Heat always flow from hot to cold, and there must be a temperature difference to heat for flow. How is heat exchanged? These are the methods of thermal energy transferring. First of all is conduction, second is convection, and the third is radiation. Most heat exchangers for HVAC purposes was conduction and convection. Radiation heat transfer does occur, but it makes up only a small percent. First method is conduction. Conduction occurs when two materials of different temperatures physically touched. For an example, if we place a cup of coffee on the table for a few minutes and remove the cup from the table, it will have conducted some of the thermal energy. Second method is convection. Convection occurs when fluids move and carry the thermal energy away. This can occur naturally or by mechanical force, such as using a fan. For an example, when you blow a hot spoon of soup, you blow onto the spoon to cool the soup down, and the air carries the heat away. Third method is radiation. Radiation occurs when a surface emits electromagnetic waves. Everything, including us, emits some thermal radiation. The hotter the surface is, the more the thermal radiation it will emit. For an example, the sun. The heat from the sun travels with electromagnetic waves through space and reaches us with nothing in between. These are the fluids used. The fluids used is water, air, steam, gas, and oil. HVAC usually do one or two things. They either heat and cool water or air. Some are used to cool or heat equipment for performance reasons, but the majority we used just to condition air or water. That's all from me. Now I'm give it to my partner King.
Hi, Assalamualaikum. My name is Sajjad Ahmad bin Refrigeration. I want to present about types of heat exchange. First, parallel flow and counter flow. In the simple heat exchanger, two fluids, one cold and one hot, move in the same or opposite direction in a concentric tube configuration. When the fluid enter and leave at the same end, the arrangement is parallel flow, whereas in the counter flow configuration, the fluid enter and leave at the opposite end. So that is the example of parallel flow and counter flow. Next, cross flow. The fluid can also flow in perpendicular direction, which is known as cross flow arrangement. The two main types are fin and unfin tubular. With a fin tubular heat exchanger, both fluids are unmixed. The one between the fins is straight in a direction transverse to the tube flow direction. In the unfin exchanger, heat can be exchanged in all directions, and the fluid can mix. Next, double tube heat exchanger. Double tube heat exchanger use what is known as the tube within a tube structure. There are two pipes where one is grooved inside the other. Just like the example above, one fluid flows through the inner pipe while the second fluid flows around the first fluid in the outer part. Shell and tube heat exchanger. A shell and tube heat exchanger is designed with a number of tube plates inside a cylindrical shell. If need to cool, if need to cool or heat a large amount of fluid or gases, the application of the shell and tube heat exchanger is an option, while smaller in size compared to some of the other types. A shell and tube heat exchanger can be easily broken down, making cleaning and repair easy. Plate heat exchangers. Metal plates are used to transfer heat between two fluids. The plate is a metal shell with space inside each plate that acts as always for fluid to travel through. With a plate heat exchanger, there is a greater surface area in contact with the fluid, so it has better rates of heat transfer compared to all other types. This type of this type of heat exchanger is best used in places like power plant because of its durability and low repair rate. Pillow plate heat exchanger. A pillow heat exchanger is commonly used in the dairy industry for cooling milk in large direct, direct expansion stainless steel bulk tanks. The pillow plate allows for cooling across nearly the entire surface area of the tank, without gaps. The wood anchor between pipes welded to the exterior of the tank. The pillow plate is constructed using a thin sheet of metal spot welded to the surface of another thicker sheet of metal. Last, cross-flow air-to-liquid heat exchanger. This is a heat exchanger that is found on the top buildings and is for instance needed for air conditioning inside. Here air fluid is leaded between the plates at the top of the heat exchanger, flow horizontally. Air is blown vertically against the plates to cool the fluid.
Okay, Assalamualaikum. My name is Fakulwah Ilham Shah bin Roslan. My matrix number is 01DPU1F1031. And my class is DPU3A. Okay, today I want to present about calculation for topic 5. Uh, this is question about parallel current flow. Okay, first, this question is asking about hot air 62 Celsius is cooled up to 38 Celsius degree by means of cool air at 11 Celsius degree. Okay, so mass flow rate of hot is 1.21 kg per second, and for cool air is 1.2 kg per second. Okay, specific heat of hood of hot and cool air are 1.02 kJ per kg K. Overall, heat transfer for coefficient is 76 W per m square K. So this question is asking about find the logarithmic mean temperature difference of the heat exchanger and surface area for heat exchanger for parallel flow heat exchangers. Okay. Okay, for this slide is given data that has give from the another question is hot air uh, is formula give THI is 62 Celsius degree and THO is 38 Celsius degree. And for mass flow rate for hot is 1.21 kg per second, and U this coefficient is 76 W per m square k. And at the right side is cool flue, cool air. TCI is 11 Celsius. M dot cool is 1.2 kg per second, and CPH equal to CPC and equal 1.2 kg per kg K. Okay, now we want to solve the solution. Okay, um, for find the LMTD is firstly we should be to find the Q, nilai Q. Okay. For LMTD is formula is that give delta T1 minus delta T2 divide ln delta T1 divide delta T2. Okay, and next we entering the nilai yang diberi di soalan, masukkan dan selesaikan dengan baik. And the last answer is 16.61 Celsius degree. Okay, for this slide is you can see two diagram. One is about solution. For next question is surface area. Q, this formula is Q equal U ALMTD. This is multiply solve. And just pindah-pindahkan semua tu. And the last answer I get is 23.46 m square. Okay, and for diagram parallel flow heat exchanger, and you can look and see the hot fluid is low and cool fluid is up. Diagram. Okay, thank you. Okay, for next question is counterflow heat exchanger. Okay, water mass equal 1.3 kg per second. CP equal 4.182 kg per kg K. Is heated from 35 Celsius degree to 65 Celsius degree by an oil mass equal 1.5 kg per second. CP equal to 1.4 kg per kg K. Entering is 1035 Celsius degree in a counterflow heat exchanger. If overall heat transfer coefficient is 3345 W per m square K. So the answer is asking to solve about calculate the log mean temperature difference and surface area required. Okay, and you should be to throw out the given data at this to do the solution. Okay. Okay, for the solution is macam biasa, masukkan semua nilai tu dan we go first to delta T1 is formula equal THI minus TCO. Okay, and the answer is 40 Celsius degree. And for T2 before delta T2 is we should be to find the THO first. and I get the answer is 57.33 Celsius degree. Okay, for delta 2, delta T2 is equal is THO minus TCI, and the answer I get is 22.33 Celsius degree. Okay, and lastly is for solution and diagram of current flow. Is okay, you can macam biasa LMTD kita dapat jumpa menggunakan dengan formula delta T1 minus delta T2 divide ln delta T1 divide delta T2, and I get the answer is 30.35 Celsius degree. Okay, and this second question is surface area. Use the formula Q equal U multiply A multiply LMTD, and I get this answer is 15.58 m square. Okay, that's all for this calculation for this today that I present. And at the beside, the right beside is diagram of current flow. It is, you can see about to TCO, TCI up to TCO, and THI down to THO. For left is delta T1, and this right is delta T2. Okay, thank you, that's all.